Okay, thank you, Angela. As Angela said, my name's David Green, and the content of this webinar is split into 4 parts. The first part is presented by myself and will inform the audience of what cooperative ITS is, its benefits, its developments internationally, its applications, and how it requires a three-way partnership between government, industry and users. The second part, also presented by myself, introduces the Austroads ARB work program, outlining key projects undertaken, including this Cooperative ITS strategic plan. The third part is presented by Stuart Bilingual and discusses aspects regarding the CIT strategic plan, including policy and regulation, spectrum management, technical standards, platform requirements, operational arrangements, and trials and demonstrations. The final part is presented by myself and involves some concluding remarks and opens the opportunity for you, the webinar audience, to ask questions using the Questions Webinar tab. So what is Cooperative ITS? Cooperative ITS refers to the use of wireless communications between vehicles and with roadside infrastructure. As shown in the figure here, roadside infrastructure is communicating to vehicles and vehicles are communicating to other vehicles and infrastructure. This enables the next generations of systems that cooperatively work together to deliver safety, efficiency and environmental outcomes. While CITS enables the whole transport system to be connected rather than just specific elements as currently occurs. It is the CITS connectivity between road users and road systems that is the focus. So through the wireless communications, CITS is able to deliver applications such as an intersection safety application as shown here, where as a result of 2 opposing vehicles being wirelessly connected to one another, they are able to be continuously aware of each other and therefore detect potential critical situations and provide appropriate warnings to the driver or action to the vehicle, such as braking. CITS is also able to communicate information from the roadside infrastructure to vehicles such as signal phasing information, which can be used to aid signal compliance, as shown in the diagram here. The primary objective of CITS is to improve safety, to improve productivity, efficiency and environmental outcomes of the road system, and to provide enhanced services to all road users and operators through giving advice or facilitating actions. Whilst no one single application is likely to justify the introduction of CITS by itself, it would be the cumulative benefits across these areas that would provide a positive return to the community. The benefits that CITS potentially offers with respect to road safety is a reduction in the number of fatalities and injuries through the introduction of active road safety systems. It is noted that a US DOT study, US Department of Transport, found that 82% of crashes involving unimpaired drivers could potentially be addressed by V2V technology. In addition, an Austroads study undertaken by Australia's MUARC found that with the entire fleet fitted with cooperative ITS technology, that serious casualty crashes could be reduced by 25 to 35%. The benefits that CITS potentially offers with respect to productivity, efficiency and environment are reduced delay times and vehicle operating costs arising from the incidence of congestion, improvements in the productivity of infrastructure use, reduction in the costs associated with infrastructure provision and management, increase in transport system efficiency, and reduction in the negative impacts of transport on the environment. In addition, CITS offers the potential for provision of additional services to road users and road operators. The CITS platform will use various communication mediums depending on the application to be delivered. Communications to be used include the 5.9 GHz or dedicated short-range communications, cellular networks such as 3G, 4G, LTE, Wi-Fi, WLAN, radio and GNSS. SITS is part of the broader ITS architecture, and as it enables efficient V2V and V2I communication, it enhances the data exchange between the four ITS entities of the ITS architecture, that being travellers, centres, vehicles and field devices. The definition of cooperative in cooperative ITS refers to the provision of wireless connectivity between the vehicles, V2V, vehicles and roadside infrastructure, V2I, and roadside infrastructure and vehicles, I2V. SITS also may evolve to include connectivity with travellers such as pedestrians and bicycle riders through the use of portable personal devices. There's essentially three types of SITS messages, and they include the vehicle here I am message, the vehicle event triggered message, and the infrastructure message. The vehicle here I am message is periodically transmitted and contains data on the vehicle status, such as latitude, longitude, altitude, heading, speed, vehicle type, etc. The vehicle event triggered message is generated based on the detection of an event and contains data pertaining to that event, such as the detection of a hazardous location, precipitations, road adhesion, visibility and wind. The infrastructure messages are generated from roadside ITS infrastructure and contain data such as traffic conditions, road closures, warnings, signage, dynamic speed signs, traffic signals, railway crossing alerts, etc. And the next few slides show some example SITS applications utilising these messages. So in this example, we've got a railway level crossing application where the railway level crossing infrastructure can communicate an infrastructure message to a vehicle outlining the status of the level crossing. In addition, trains may be also equipped with devices in order to communicate a here I am message to the vehicle. In this application, we've got a roadworks warning. So portable infrastructure may be erected at roadworks in order to communicate advanced warning of the roadworks along with other information such as speed limits. Here we have a traffic jam ahead warning or congestion warning, and this kind of shows as a result of vehicles communicating its here I am message, vehicles approaching a congested spot or a traffic jam or a queue can be made aware of a leading vehicle and therefore be issued a warning to apply its brakes. Here we have a hazardous location warning, and these warnings could be delivered through an infrastructure message from smart infrastructure that is able to detect a hazard using data collected from its own sensors such as weather data. Alternatively, a vehicle, as showing in the figure on the right, may detect a hazard situation and send an event-triggered message to other vehicles in the area and or infrastructure if available. Other SITS examples include in-vehicle signage, including contextual speed, floating car data and identification of traffic conditions, traffic information, strategic routing and recommended itinerary, and intersection applications including intersection safety, green wave, energy efficient intersection control and traffic light optimal speed advisory. So those last few slides and this slide are just examples of some of the SITS applications that are evolving in the initial term, but there'll also be the opportunity to provide more applications is endless. The successful deployment of SITS will require a three-way partnership between road users, the industry and governments, where the primary role of the government would be to establish policy and develop the regulatory enablers for SITS to be deployed. Industry would bring to market various applications, largely driven by global industry, for consumers to take up, with local industry playing a key role in adapting and deploying these applications into the local market. And of course users would need to adopt the technology, where the level of their uptake of that technology would determine the ultimate success of cooperative ITS. Internationally, there is a large amount of work being undertaken on SITS, with regions working towards deployment from 2015 onwards. This includes in Europe, USA and Japan. For example, in Europe, the European Commission has issued Mandate M453, the minimum standards for cooperative ITS, and the European Commission has funded various projects and trials, including the Drive C2X, and the European Car-to-Car Consortium has established an agreement for 2015 deployment of SITS-equipped vehicles. In the USA, there have been various trials on a wide range of SITS safety applications, including the US DOT Safety Pilot in Michigan, comprising of almost 3,000 vehicles. Also, the National Highway Traffic Safety Administration is making a decision on whether mandating V2V communication is feasible. Japan has begun deploying SITS safety systems across its network, including the SmartWay project, which is a cooperative vehicle highway system using V2I technology, and the seen a deployment of over 1,600 ITS spots using DSRC communications across Japan's expressways. Also, Japan have got the Driver Safety Support System project, which is an I2V safety initiative for urban roads using infrared technology. Now that you know what SITS is, its benefits and how it can be used, I will now go to part 2 of the webinar and discuss the Austroads ARB SITS work program. Austroads, as a representative of the Australian and New Zealand government, has identified that as international regions are looking at deploying SITS for 2015 onwards, there is now increasing recognition of the need for Australia and New Zealand to be ready to adopt and adapt SITS and deploy it in the local region. As a result, Austroads has been working with local industry since 2006 on getting Australia and New Zealand ready to adopt, adapt and deploy SITS locally. ARB has been working with Austroads since 2008 on various SITS-related projects. In 2008, ARB or ARB prepared an Austroads report on the case for securing 5.9 GHz as part of an Austroads project, NS1206. Since 2010, work undertaken by ARB on the Austroads SITS work program has been through the Austroads projects of NT1632 and NT1785, as outlined on your slide there. Investigations that ARB has led under NT1632 and NT1785 include the Cooperative ITS Strategic Plan, the 5.9 Spectrum Management and Device Licensing Regime Report, Satellite Interference Study, a Vehicle Positioning for Cooperative ITS Report and Study, a study into emerging digital mapping requirements for SITS, and a Cooperative ITS International Engagement investigation, which was a review of international engagement needed to be undertaken to keep Australia up to speed with respect to international developments, an investigation into the concept of operations required for a core SITS system to be developed locally, and an investigation into SITS interoperability with existing ITS infrastructure. As you can see those on your slide there, the first 5 projects resulted in a published report, and those Austroads published report numbers are shown on your screen there and can be accessed through the Austroads website. The key findings from the various projects undertaken as part of the Austroads ARB work program will be discussed further in part 3 of the presentation. So now I'll pass you over to Stuart Bilingual, the Austroads Cooperative ITS Project Director, who will discuss the strategic plan for SITS, which will include a detailed description of the priority actions being taken to establish a local framework for SITS deployment. I'll pass you over to Stuart.
Good afternoon, everyone. Thank you for joining us. I hope you can hear me clearly. What we're going to go through here in part 3 is the framework that Austroads is taking a lead role in establishing It's an operational and regulatory framework that will enable the deployment of cooperative ITS locally. A key or foundation document that will guide the establishment of this framework is the Cooperative ITS Strategic Plan. This strategic plan has been developed to define the mission, vision, objectives, the guiding principles, and those key foundation activities that are required to establish a cooperative ITS framework locally. As David mentioned before, the Cooperative ITS Strategic Plan has been published. It was published in August of 2012, and it can be accessed on the Austroads website. Within the Cooperative ITS Strategic Plan are a set of policy principles that were basically guiding principles to guide decision-making in this field in future. These policy principles were endorsed by the senior transport officials in the TISOC committee in September 2012. Also in the Cooperative ITS Strategic Plan, it outlines the priority focus areas in establishing a cooperative ITS framework locally. Those priority focus areas on your screen there are policy and regulation, spectrum management, technical standards, platform requirements, operational arrangements, and trials and demonstrations. What I'm going to do now is I'm going to go through each of those priority areas and just give you a quick overview of some of the key activities in each. Starting with policy and regulation. The top document you see there on the top right is the policy framework for intelligent transport systems in Australia. This sets a policy framework and foundation actions for ITS deployment in Australia. So that document sets policies in place broader than just cooperative ITS, but there are a number of foundation actions in there that are requirements or are specific for cooperative ITS, so it does provide a guiding policy document for us. This national policy framework was endorsed by the Transport Ministers within SCOTI in November 2011. Next document here is the National Transport Commission's Regulatory Policy Review, and you'll see a cover of their discussion paper at the bottom right of your screen there. The NTC are taking a lead role, working closely with Austroads, in reviewing those regulations and government policies that may have implications for the deployment of cooperative ITS in Australia. In particular, the NTC review is looking at the focus areas of privacy, so particularly looking at the Privacy Acts, National Privacy Principles, Surveillance Act, etc. Also looking at liability, driver distraction, and compliance and enforcement, and particularly looking at where data can or cannot be used for compliance or enforcement purposes, so the data that is created by cooperative ITS. The NTC discussion paper was released in November 2012. 24 submissions have been received, and NTC are currently going through reviewing those and also doing more targeted consultation based on the key issues that were raised. Next step is to put together a final paper which will include any recommendations to do with regulatory or policy change that is deemed to be required, and that will be put to both TISOC and SCOTI later this year. Another key action under policy and regulation is a review of the Telecommunications Act. This act regulates what carriers and providers can and can't do, particularly with regards to providing communication services to the public. Because of the way that cooperative ITS works, this does have potential implications for the licensing and use of cooperative ITS. So Austroads has been undertaking a review of the Act and its implications, and to determine whether there is a need for a telecommunications carrier license to be taken out. Initial legal feedback suggests that this may not be the case, but it's still a review that we need to proceed with. Next priority area of focus is spectrum management. Now, as David touched on before, cooperative ITS potentially uses a range of wireless communications technologies, but most of those are well established. The one area of wireless communications that isn't well established in Australia is for dedicated short-range communications, which in Australia we're looking to have allocated in the 5.9 gigahertz band. The United States and Europe have both formally allocated the 5.9 gigahertz band for ITS. In Australia, we are yet to formally allocate the 5.9 band for this purpose, but in 2008, the Australian Communication and Media Authority did issue an embargo called Embargo 48, which is still in place and so is protecting the 5.9 band from any future allocations while we plan for the deployment of ITS. Austroads is undertaking a number of key activities that need to be done in order to formally allocate the 5.9 band for ITS, and I've listed some of those on the screen there. First of all, we need to determine what potential interference issues there might be, and as part of that work, we've identified and investigated a number of potential interference sources. You'll see that image on your screen there of the large Earth satellite dish. That's what we call a fixed satellite service dish, and working with ARB and La Trobe University, we've done field studies at a number of these satellite uplink sites to determine what level of interference there might be and to determine whether coexistence might be feasible. Once we've done that, we need to determine what coordination criteria might be required. So the 5.9 band almost certainly won't be exclusive to ITS. There will be other co-primary users within the band. So where coexistence is necessary, we need to determine an agreed set of coordination criteria that will enable us to operate together within the band. We also need to look at what device licensing regime is needed. As David mentioned before, we've previously published a report looking at what options exist for device licensing. This includes certification of devices to operate within the band. We need to look at how the band will be allocated. So within the 5.9 band, which channels may be for safety and which channels might be for non-safety purposes. And finally, we need to determine the governance and management arrangements. And the intention at this stage is for Austroads to be nominated as the interim management entity for ITS in the 5.9 band. But in doing that, we'll need to work towards determining what the ongoing or permanent management entity might be and what those governance arrangements might be. So there's certainly a significant job of work to do there. Moving on, the next key priority area is technical standards. Now, technical standards are quite critical. They enable interoperability and compatibility. They ensure fitness for purpose. They create trust in products and services that are brought to market. They prevent duplication and they reduce barriers to market. So the adoption of technical standards is very, very important in this space. Within the Cooperative ITS Strategic Plan and its policy principles, we have a key policy principle that says that we should adopt or harmonise with international standards and international best practices wherever possible. And this is largely because we do not want to have a situation where we have unique standards or unique requirements in Australia. We do want to be part of a globally harmonised framework for cooperative ITS. The approach that's being taken globally in the development of cooperative ITS standards is that we'll do them in a release approach. And what that means is that cooperative ITS inherently is a holistic system of systems that work together. And so what you want to be sure of is that the standards that are released are interoperable or they enable interoperability. So by doing a release approach where a large set of performance or technical standards are released at once, you have confidence that those standards will enable interoperability. So there's a lot of work being done globally at the moment on what they call the Release 1 of cooperative ITS standards. The key areas in which these standards cover are pretty much aligned with the architecture for an ITS station. And so you'll see that there'll be sets of standards around applications, around facilities, which includes the data messages that David spoke about earlier. There's a set of standards around networking protocols, around access and communication or media technologies, and also around management, architecture, and security. And as you can see in that image in the bottom right-hand side of the screen, there are harmonisation agreements between the three main international regions, being Europe, the US and Japan, so that these standards, as much as possible, will be harmonised globally. Fourth priority area of focus is platform requirements. What a platform is it's the technical environment that enables cooperative ITS to effectively operate. So it's that technical environment at which applications will be introduced into or deployed into. Touching on what we talked about under technical standards earlier, it's very important that this is harmonised with global standards and best practices wherever possible. Some of the key areas of focus that we've had to date in establishing the local framework are the ones you see on your screen. So a lot of work has gone into communication networks, particularly looking at the 5.9 gigahertz band, ensuring where possible that's harmonised with practices overseas, but also other technologies such as cellular. There's a lot of work going on looking at security, and this is quite a significant risk to the cooperative ITS environment. We need to ensure that the standards and practices in place protect against unauthorised access and use, and cyber threats, malicious acts, etc. So this is quite important. Architecture is also a key area of focus in the platform. Having a common framework or a common architecture is critical to ensure that systems are integrated and interoperable. Positioning is a key area of focus. As what the report that Austroads has just published points out, many of the international cooperative ITS trials and deployments that have occurred to date have utilised what we call an augmented GNSS, or Global Navigation Satellite Service, to meet the vehicle positioning requirements. In Australia and New Zealand, we don't have access to an augmented GNSS, so what we're looking to do is provide input to the National Positioning Infrastructure Plan that's currently being developed, so that the needs of cooperative ITS are well considered. That image that you see on your screen on the bottom right is from the Austroads report into vehicle positioning, and it just maps out the way that an augmented GNSS works. So you can see that it's a mix of satellites, geostationary satellites and ground reference stations to achieve that augmentation that's required. The other key area that I was going to point out in the platform is around digital roadmap data. A number of cooperative ITS applications and also advanced driver assistance system apps require access to accurate and timely map data, and so there's a job to do there to review the data supply chain that we have in Australia and New Zealand and look at how better we can provide the required map data to cooperative ITS applications. Second last priority area is around operational arrangements. A key piece of work that we're doing at the moment is developing a concept of operations document for the core system of cooperative ITS. What a concept of operations is it's a foundation systems engineering document. It describes the system in its whole, what its functions are, who the stakeholders are, and what their roles and responsibilities are. So it helps guides future steps in a system engineering process around requirements and system design. So it's quite a critical piece of work, and we're looking to hopefully finalise that next financial year. We're also doing work with ARB, researching interoperability with existing ITS, so ITS that's currently operated by the road authorities. We've decided to hone in on 4 existing ITS, being variable speed limit signs, traveller data collection systems, traffic signal systems and traveller information systems. And in doing that, we want to look at the feasibility of cooperative ITS-enabled vehicles being interoperable with our existing ITS, and also to highlight what the risks and benefits are. Another key piece of work is to determine a sustainable business model. It's one thing to determine that all of this is technically feasible. It's another to work out how it's going to be funded and sustainably funded into the future. So that's a piece of work that we'll need to do in the coming year, and we will be guided by global developments. The rest of the world's trying to resolve that problem as well. The final thing I was going to point out here was around the management entity. As I pointed out earlier, Austroads is about to be nominated as the interim management entity for cooperative ITS in Australia, but it's not Austroad's intention to continue to take on that role ongoing. And so there's a piece of work there to investigate and determine what the ongoing governance and management arrangements should be. The final priority area in the framework is trials and demonstrations. Now, there's a whole swag of trials and demonstrations that have been going on internationally for quite a number of years now. They're often referred to as FOTs, or field operation tests. The main regions that have been progressing these are in Europe, USA, and Asia, and largely in Japan and South Korea. These have been very important because they've enabled us to test and validate cooperative ITS technologies in real-world situations, so not just in theory. And you'll see the two images I've put on the screen there are of a vehicle that's equipped with cooperative ITS technology that was used in one of the European programs. So you can see how it doesn't even look like a trial car. It gives you an idea of the level of maturity of this technology. It looks like it's come straight out of a showroom. Now, local trials are also very important, so we shouldn't just rely on trials and demonstrations that are done overseas. Now, the reason why local trials are important is because they enable us to assess and validate cooperative ITS in our local environment, because there may be some things in Australia and New Zealand that are unique and that we do need to consider. They enable us to plan for local deployment better. They also help us to be more of an international participator and to and show that we can harmonise with international standards and best practice. But they also help us locally to promote the benefits and to encourage uptake. If we don't get the required level of uptake, then the road safety benefits that David touched on earlier will be more difficult to achieve. So trials will really help promote and encourage uptake. Now, we have had quite a few local trials, and I've listed a few on the screen there, which include the Connect Safe trial that was done in Adelaide in 2010 and 2011. There was a railway level crossing trial in Victoria that was project managed by La Trobe. And there's also another railway level crossing trial that's about to commence in Queensland as well. There's the CITI project, or the Cooperative ITS Initiative project, which is looking to establish a 42-kilometre cooperative ITS testbed in the 42 kilometres of highway leading into Wollongong and Port Kembla, which is just kicking off at the moment. And the other one I've got listed there is a Smart Rest Areas project, which is also just about to kick off, which is looking at instrumenting 7 truck rest areas on the Newell Highway in New South Wales, and probably have around 30 cooperative ITS equipped trucks linking to those. So you can see we already are active in Australia in conducting localised trials, but there is a need to possibly do more, but definitely to promote the benefits and encourage uptake based on those trials. That pretty much summarises my part of the presentation, so at this point I'll hand you back to David.
Okay, thank you, Stuart. Well, as you can see, SITS has great potential to provide many benefits for the road system. International regions are working towards deploying SITS from 2015 onwards, and as a result of developments internationally, Austroads, on behalf of Australia and New Zealand, has commenced investigations into setting up the necessary regulatory and operational framework to facilitate the deployment of SITS locally. Now we will open the opportunity for you, the webinar audience, to ask questions via the questions tab. So feel free to start submitting those questions now. But in the meantime, while questions are coming in, if you want further information, please contact myself, David Green, or Stuart Bilingual on the details provided on your screen. To access reports referred to in this presentation, please go to the Austroads website at www.austroads.com.au, and you can access the 6 Austroads published reports undertaken by ARB by searching under NS 1206, which was the one report on securing the 5.9 gigahertz spectrum, and under NT 1632, which had the 5 reports related to the Cooperative ITS Strategic Plan, the Spectrum Management Report, Interference Study, Positioning Report, and the Mapping Report. And if you want some further information about ARRB and the work it performs, that can be found at www.arrb.com.au. Okay, well, we've got a question in here. And the question's from, I'll just read out the originator of the question. The question's from Paul Gelston. And is anyone doing any work in the cooperative ITS space that specifically looks at the benefits for public transport vehicles using the road system? All public transport users and vehicles are one of the potential benefits of cooperative ITS. At the moment, I guess the main focus is on V2V type technologies and V2I. But that would also include, as SITS evolves, benefits to the public transport system and to the users in providing information about intermodal transport, and it can also be used to provide applications such as signal priority measures. But you also got to remember a lot of those public transport applications are currently being delivered through existing technologies. Did you want to add any further, Stuart?
Yeah, I might add a little to that, and thanks for the question. Certainly, cooperative ITS is very much multimodal. While a lot of the images you see might have cars in it, there certainly is a lot of work globally looking at other forms or modes of transport, such as heavy vehicles, motorbikes, public transport, etc. I touched on very briefly in my part of the report that there's been a large number of trials and demonstrations overseas. There's been a few in Europe that have looked specifically at public transport. Most of their focus has probably been on prioritisation at signalised intersections, I have to say. But there certainly has been a focus there on public transport, and I don't have the names of the trials at hand at the moment, but I can assure you there has been quite a bit of work there. The significant North American trial that's being done in Ann Arbor at the moment, where there's just under 3,000 vehicles equipped, within that there's a handful of buses that are used for public transport, so they are looking at how that interacts with the whole road system as well. And also, as we pointed out in the presentation, there's been some local trials of how to improve the interaction of trains and road-based vehicles at grade crossings. So that's another example of where we've looked at the interaction with public transport.
Okay, we've got a few questions coming in. The next question is from Tom McHugh, which is from Main Roads WA. And he asks, would you talk a little more about the long interim period where only a small percentage of vehicles will be initially equipped, growing over time, and then what challenges does this create, and how does this impact the benefits realisation? Yeah, well, as we said earlier on, the benefits will be very much impacted upon by the uptake of the technology. So yes, that presents quite a significant challenge for cooperative ITS and the magnitude of the benefits that it provides. With cooperative ITS, you're really relying on vehicles being able to communicate to other vehicles and to other infrastructure. So yeah, it'll be the role, and that's where I guess trials and demonstrations, as Stuart touches on, highlighted the importance to be able to communicate the benefits to users in order to promote their uptake. Did you want to add any more, Stuart?
Yeah, I might add a bit, although the questions are coming in so thick and fast that the questions have been pushed off the page. Okay, so you're talking about the period of time at which the proportion of vehicles on the road that are equipped with cooperative ITS is low. This is a little bit of a chicken and egg situation. and it certainly does affect promoting uptake, because if people don't realise or recognise the benefit, then why would they invest in it, particularly if it's not mandated? That does present a challenge for transport authorities, and there will need to be decisions around what sort of services, particularly infrastructure-based services, could be introduced so that a more immediate benefit can be experienced by motorists, and that would then in turn help encourage uptake. So there are some decisions around that, definitely. But even if this sort of technology was to be mandated, which is the sort of approach the US is considering, the best you're looking at is introducing 5% to the vehicle fleet that cooperative ITS equipped a year. So it would take 10 years even to get half the vehicle fleet equipped. Moving on, the next question sort of lines up with that, from Richard Ferme. When is it expected that we should start to deploy roadside infrastructure to support CITS equipped vehicles in Australia? As we mentioned in the presentation, Austroads and ARB are doing a few pieces of work in this space at the moment. The one that probably most aligns with this is our research into interoperability with existing ITS. Through that work, we're looking to identify the feasibility of those 4 ITS types that were identified and what sort of actions would be required to make them interoperable. Cooperative ITS in itself does not need roadside equipment. It's a peer-to-peer network, so vehicles can actually communicate without any roadside equipment. Having said that, though, as per the answer to the last question, there is benefit in enabling applications that require roadside infrastructure, so there are some decisions that road authorities in Australia and New Zealand are going to have to make. It is very unlikely that we'll see CITS equipped vehicles, or at least 5.9 gigahertz equipped vehicles in the next 2 years in Australia, but from 2016 onwards it's very likely that we will start to see them. So I can't imagine that we would need to have CITS equipped roadside infrastructure for 2 or 3 years yet, so we have a bit of time to make that informed decision.
Okay, the next question is from David Stewart. He asked, do any of the reports discuss possible integration with traffic signals, with signal phasing and timing data in Australia? That's one of the reports we're currently working on now, which is SITS interoperability with existing ITS infrastructure, with a focus on the existing ITS infrastructure being variable speed limits or electronic speed limit signs, traffic signals, traveller data collection systems, and traveller information systems. The next question is from Ivan McCann. It says, what sources for environment, traffic and incident information are you currently identifying and working with across the Australian states? Again, they'll probably follow on with the work we're doing at the moment, which is the interoperability project, and looking at how SITS could be made interoperable with traveller data collection systems to provide information to vehicles.
And the MUARC report.
And the MUARC report. The next question here is from Hussein Parsa. I hope I pronounced that correctly. He asks, as far as I know, private sector is leading ITS initiatives in Europe. What is the state of play in Australia? I might pass that over to Stuart to answer.
Thanks for the question, Hussein. In North America, if I could use that as a first example, they're probably taking more of a regulated approach, or at least trying to take more of a regulated approach. So if you look at the trials that have been done over there, a lot of them have been driven by government, particularly by the US Department of Transportation. And that major trial they're doing in Ann Arbor, the data that comes from that will be used for an agency decision at the end of this year, which will either recommend to mandate the technology or to put in place policy that will significantly increase its uptake. If you look at the European approach, theirs is probably less of a government-driven one. It's probably more of a market-driven approach that they're taking in Europe. So government in Europe, or the European Commission in Europe, have basically said, we'll look to put in place the standards and framework the market requires, but we'll then leave it to the market to develop the technology and bring it into vehicles and to road transport systems. In Australia, there hasn't been any formal decision on which of those approaches is more likely, but all things are heading that they would be more similar to the European approach, where we'll look to put in place the framework that is required, but let the market introduce it. But having said that, that decision hasn't yet been made. The next question is, has any work been done on a benefit cost analysis for cooperative ITS in Australia? Yes and no. There's been, not as a holistic system, I'm unaware. There's certainly been some benefit cost analysis around collision avoidance technology specifically. So if you look at the Austroads report that was done a couple of years ago, that MUARC was engaged to do for us, that looked at benefit cost to a degree, but its focus was very much on collision avoidance type technologies enabled by cooperative ITS. At this point in time, I'm unaware of any benefit cost analysis that has been done for the whole cooperative ITS ecosystem as a whole. Next question, are you examining the use of cooperative ITS with respect to increasing heavy vehicle safety? Definitely yes. Two of the trials we had up on screen before, being the CITI project in Wollongong and the Smart Rest Areas project on the Newell Highway in New South Wales, both of those are specifically focused on heavy vehicles. In fact, the cooperative ITS test bed that they're looking at establishing running into Wollongong will hopefully be a test bed that can be used for all sorts of heavy vehicle applications. Internationally, there have also been a large number of trials that are very, very specific to cooperative ITS for heavy vehicles. Main one I can think of is in North America, called Smart Roadside Initiative, SRI. So if you were to Google that, you'll see they've done some significant work looking at cooperative ITS for heavy vehicles specifically. Next one, what vehicle manufacturers have been involved with the ARB research to date? Even though it says ARB, I might help answer that one first. The automotive industry have been closely involved. We have an industry reference group that we've used with the Austroads Cooperative ITS project for a number of years now. The Federal Chamber of Automotive Industries has a representative on the industry reference group, and at least 2 auto manufacturers have been very active on that group as well. When there's been a need for us to consult with the automotive industry, each of those representatives have been extremely valuable in their time and in providing input to the work that ARB and Austroads has done. So yes, they have been closely involved.
That was pretty much where I was going to lead my answer, so I don't have anything more specifically to add to that. Thanks, Stuart. We've got another question in here from Tom McHugh. Has any work been undertaken looking at the impact or refinement of the operational role of road authorities in managing the road network under cooperative ITS? I'll pass.
Unfortunately, with this sort of webinar approach, it makes it difficult to check exactly what the question is getting at. So my apologies if I don't answer this properly. It says, has any work been undertaken looking at the impact or redefinement of the operational role of road authorities? No. I don't believe that we've looked at that higher level at this type of technology deployment changing the operational role of a road authority too much. But in the work we'll need to do in establishing the management entity for cooperative ITS and the work that we are doing looking at the licensing requirements for the 5.9 gigahertz band, it could be that there are additional functions that a road authority has to do in that space, particularly if it is transmitting data wirelessly to the public. So it's not necessarily redefining the operational role, but there could be a few additional functions added to the current role. Hopefully that answers the question. Next question. Can you please recap on the work being undertaken regarding the business model for cooperative ITS? That work is only just about to commence. I mean, some of the pieces of work we've done previously, particularly in establishing the cooperative ITS strategic plan, if you look at the document around the device licensing regime and spectrum management, and a few others, they do touch on elements of what we'll need to include in the business model, but we're yet to, as a dedicated piece, start putting together what the options are for a business model ongoing. That's a piece of work that we'll be doing in 2013 and 14. And just to add to that, our colleagues internationally are at a similar stage. No one's quite refined what the feasible business models are yet, and we do want to make sure that we're going to be aligned with whatever the global developments are in that space. Next one. I saw demos from Coda and Nokia. Are they involved in cooperative ITS? Yes, both of them are. For those who don't know, Coda Wireless are an Australian-based company based out of Adelaide, and have been heavily involved with developing technology and services, particularly in the 5.9 gigahertz DSRC space, and have also been active not just in the local trials we mentioned before, but also in a number of international trials. Coda also have a representative on our industry reference group, and we've consulted them widely throughout the cooperative ITS program at Austroads and ARB. Nokia, we have good contacts at Nokia as well, and previously Navtec. And yes, they've also been involved and consulted during the cooperative ITS program as well. Next question. Augmentation of GPS would seem to require significant investment. What are the prospects of this occurring in time, not to detract from safety-focused ITS applications? You're right. The options that are available for augmentation of GNSS are not cheap. As I briefly mentioned in the presentation, Geoscience Australia have been asked by the Commonwealth Government to develop the National Positioning Infrastructure Plan, the NPI plan. They've pretty much finalised the NPI plan, but it hasn't gone to Cabinet in Canberra yet, so it hasn't been published. In putting together the NPI plan, Geoscience Australia and its stakeholders have considered a number of options for providing a ubiquitous augmented GNSS service throughout Australia. One or two of the options that are in there are not as expensive as you would imagine, and they're a bit of a hybrid approach of satellite and ground-based augmentation. It's a bit difficult for me to go into too much detail about it because it hasn't been approved and published at this stage. But even if they were to go for one of the cheaper options that will be looked at there, yes, you'd be talking a couple of years before it would be deployed. Next question. What happens if cooperative ITS is overtaken by automated vehicle technologies that don't require an expensive CITS architecture? The way that we like to look at that, there's actually a really good diagram to explain this. It's kind of a shame I can't put it up on the screen. But automated vehicles are going to need the same sort of wireless technologies that cooperative ITS require. Just instead of using them as warning or for a semi-controlled application, it's going to be completely controlled or automated. but it doesn't mean that the overall ITS architecture or the communication technologies involved are actually that different. They may actually complement each other. So in developing the framework that we are for cooperative ITS, we're very much cognizant of looking further up the graph, if you like, towards fully automated vehicles so that the framework can be scalable when the time comes that they need to be integrated.
I was just going to add to that the ADAS technologies, or Advanced Driver Assistance Systems, and SITS technologies shouldn't be seen as separate. Really, SITS is part of the ADAS solution, and so SITS would work with sensor technologies as they evolve and come more on the market. We'll go to the next question, and we might wrap it up shortly, but we've got time for a few more. What consideration is given either globally or locally to the public health impacts for ever-increasing levels of radiation by expanding wireless applications such as this? I'll pass that over to Stuart.
Yeah, that's definitely been considered. ACMA, the Australian Communication and Media Authority, actually have a really good document on this, where it talks about the studies that have been done into the level of radio communication emissions and the effect that it has on human cells, etc. And it draws upon global work, so it's not been done just for localised Australian context. And that is used by ACMA to sort of determine maximum emission limits for different parts of the spectrum. The sort of emission limits that are talked about for cooperative ITS are well below the levels that are considered of concern as having an effect on human cells. So in short, yes, definitely given consideration to that, and the cooperative ITS technology and the emission limits we're talking about are well under the guidelines. The next question is to do with the New South Wales Heavy Vehicle Rest Area trial. What is the actual trial? I don't know if we're the best ones to answer that. Transport for New South Wales providing the project management for that trial. It's partly funded by the New South Wales state government and partly by the Commonwealth. As I said before, it's about a 210 kilometre stretch of the Newell Highway at the northern end. It'll involve 7 rest areas that will be instrumented with a DSRC beacon, and I think it's about 30 heavy vehicles that will be instrumented. But I'm afraid I probably am not the best person, and David's probably not the best person either to provide much more info on that. That's probably more a question for Transport for New South Wales. The project manager there is a lady by the name of Angela Adams, I think her name is. So my apologies, I can't shed too much more light on that. Next question, what are the priorities for Australia for harmonisation with international standards? I'm assuming what that question is asking is there a priority for the different standards? So some standards prioritise higher than others. This is something we're actually looking to talk about at our next steering committee meeting, which is in about 2 weeks' time. So, Tom, I see that question's from you. You can participate in the discussion then. Basically, I'd like to think not. As I said, what globally they're trying to do is to develop something called the Release 1 of standards. So it'll be a minimum set of standards that's required to enable interoperability and enable deployment. There will be a job of work for us to do here to do an assessment of those Release 1 standards, but I'm not so sure that I want to go into that with some list of priority. Maybe we'll determine that once we've started the assessment.
Yeah, we'll just take one more question, and that is, considering the existing safety investigation by Newark, has the insurance industry showed interest in investing in this technology? Well, for my knowledge, the insurance industry would be interested in this technology, and are probably watching keenly to see how it evolves. Do you want to add in more?
Very, very briefly, because I'm conscious of the time, we've got to wind up. Yes, the insurance industry are very interested. Probably hasn't come to a head in Australia at this point in time, or in New Zealand, but particularly in Europe and the UK specifically, and in North America, the insurance industry are looking closely at what sort of data can be captured through cooperative ITS and whether there'll be any restrictions on its use. Ultimately, they see an opportunity to move to a user-based insurance model using the data. The work I mentioned before with the National Transport Commission will help guide us in determining what the data captured by cooperative ITS can and cannot be used for. But in short, yes, the insurance industry are interested, and we will need to consult in future.
Okay, thank you, Stuart. We'll end the presentation there. As I said earlier, if you want any further information, please contact myself or Stuart Bilingual on the details provided on your screen. Thank you.